All right, check this out. We have some more rational functions. We have x on the denominator. This time out, we're going to look at some more transformations. So we're going to have things in transformational form once again, but we are going to be transforming a slightly different graph. Okay, so what happens if instead of having x on the denominator, we have x squared? All right, well, good question. Okay, so what's happening here is, first of all, you're going to see a lot of similarities. This right here is the graph of 1 over x squared. And you can see that, first of all, we have a vertical asymptote of x equals 0. Nothing new there. We have a horizontal asymptote of y equals 0, and that's the same. We have a key point of 1, 1. That's the same. What's different is normally we would have had a curve down here and we'd have a key point of -1, -1. Okay, however, what's changing is when you have x squared on the denominator, well, if you plug in a -1 for x, you plug in any negative number for x and then you square it, you're going to end up with a positive number. So the one thing that has changed is the y coordinate of this second key point right here. And of course, if that y coordinate changes from a -1 to a +1, then it's going to be up into the second quadrant instead. Okay, so things are going to look a little different, but mostly the same. So basically, you want to adjust the one coordinate, the one y coordinate of one of your key points whenever you have a squared on the denominator instead. So we're going to take a look at this example right here, all right? So you notice this one right here, it definitely is in transformational form. You're ready to do a mapping notation. And notice that because there's a squared, an exponent of 2, on the denominator, that means you're going to use this new graph with these new key points, slightly new. So let's do a mapping notation first. That's a great place to start for any transformational equation. So this will be x minus 1 and minus 3y plus 2. Now notice that the square does not go into the mapping notation at all. We never put exponents in there. And the reason why is the exponent is part of your original function. The original function is 1 over x squared. So the squared in our new function that we have to graph, it isn't anything new. So it's not a translation or a stretch or anything like that. It just alerts us that when we do our key points, that we have to switch it up a little bit. We have to switch up this one y value right here. You should have 2 y values of +1. Okay, so that's going to be a little bit different. But we still have our vertical asymptote and our horizontal asymptote are represented by our horizontal translation and our vertical translation. So you could get to those right away if you want. You could plot those two asymptotes right away, or you can get all the information and then do all the graphing after. One thing you'll notice, okay, is that we have a horizontal asymptote at y is equal to +2. And we also have a vertical asymptote at x is equal to -1. Okay, so we have our asymptotes in. Let's get our key points. So you have to make sure that you start off with the right key points, which are slightly different, but the things that you have to do here are all the same. All right, plug these into the mapping notation, and you're going to get these new points right here. Okay, so we plug each one of those in, all right, and we get those points, and then we should graph them. So we get 0, -1, that's a point. It's also a y-intercept, but you're not asked to solve for the intercepts here. Okay, we have -2, -1 is also a point. And maybe that's enough to sketch the graph. Okay, we have asymptotes, we have key points. When doing these x squared graphs, we usually leave out the x and y intercepts. So you don't have to solve for those. You could if you wanted to, it's not too difficult. But if you have these points and asymptotes already drawn in, you can suspect that your graph will look something like this. So the asymptotes provide the boundaries, has to cut through each of those 2 key points right there. And notice that when you have y is equal to 1 over x transformations, you'll have one part of your graph on top, one part of your graph on bottom. Well, with these, okay, you're either going to have both parts on top Or if there's a reflection, like there is here, right, we have a negative in front of the 3, so there's a reflection around the x-axis, so now they're both on bottom. And then, of course, we can do domain and range as well. Domain looks similar, okay? Every x value can be part of the domain except for the x value of -1. Now, the range looks a little bit different this time, because notice that because everything is going to be on top of the horizontal asymptote, or everything is going to be below, what we can say here is that the domain in this case, the minimum is -infinity for y, but the highest that you can get is up to, but not including 2. So the highest this graph is going to get is like 1.9999, and it's never going to go above that horizontal asymptote. So our range is just in one part here instead of 2 parts, which you'll see with all the 1 over x squared graphs. So we have everything completed, not asked to do x and y intercepts for these functions right here. So what you guys can do next, all right, is you can just smash that pause button. And, well, not right now. I'll just wait until I finish talking, I guess. But you can see that question right there. I want you guys to try this out. So now you can hit that hit that pause button. And next up, okay, when you're ready, check this out. Okay, this is it right here. This is the solution. So you can check your work and see if you got the correct solution for this.